Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we are going to discuss about distributed data storage, that how a data storage can be distributed when in a parallel architecture. Now there are two processes that we will discuss today. One is a fragmentation, another is a replication. And we will see that each of these cases, how it benefits and what are the disadvantages that is associated to it. When we are talking about that we are connected in a distributed system, or we are accessing many operations or many queries inside an operation separately and individually, that is consequently we are executing them, then their need of the distributed data storage arises. Now how can we data that we are storing in a relation distribute among different query or different operations and even among different processes? We can distribute the data in two of these ways. The first one is the replication and the second one is in fragmentation. Using the replication, we use that for each of the process or operation, they need their own local copy of the data. That means the entire relation R need to be replicated if how many operations or how many processes to which they are belonging. And the next type of distributing area is the fragmentation. That means here we can see that we are dividing the storage into different disks or different section of disk so that each processor can act independently on their disk and then finally the result can be merged. So in these two ways we can distribute the storage. First we will talk about the replication. See, for the replications we are having the relation R that need to be replicated. Suppose there are P1, P2 and Pn number of processors. Now we can toggle the use of process and operations with each other, but we are using the term processors with the P1, P2 to Pn. And now we are having the relation R that needs to be accessed by each of these processors. So what we can do within this replication, we can have the replicated copy with P1 the R1, P2 the R2, and with Pn the Rn. That means each of the processors has their own replicated copy. So now they can access their part of this database on which portion they want, and they can update it and propagate the update to the other processors. Now most of the processors opt for this full replication, where the entire database needs to be replicated to each of these processors. Even if the processor needs only one portion of a database, but it needs to be copied to every processor, every part of this database. But this has got advantages and also some disadvantages. What are the advantages? The first one is availability. So now the replicated copies are available to each of the processors at every time. That means even the processor now needs a part of this R1 and later needs another part of this R1, it can go for this one with this replicated copy. That makes the database available to each of the processor at the same time. So this is main use of the parallel processing, where we can have the processor P1, P2 and Pn executing parallelly and independently of each other. The next one is increased parallelism. How you can increase the parallelism as become the database available to the users on the processors. Now the parallelism increases because the parallelism, the P1, P2 and P1 can execute independently, so they update their own copy of this R1, R2 and Rn in such a way that they need to propagate the updates in this P1 to P2 then to P1. And now we are having all the processors that are executing simultaneously to increase the nature of this parallel. But also there is an increased overhead. Again, this is term related with the previous one, that is availability and parallelism. As now, say suppose that P1 is updating its copy of Ri, or P2 is updating R2. So what is happening? Say P1 is updating the R1 in part Ri and Rj, and P2 is updating the part in Rk and Rj. So now there is a conflict that P1 is updating the part Rj and P2 is also updating the part Rj. So now P2 needs to propagate its update to the P2, otherwise P1 cannot have the modified data in which they can update this Rj. So to update and propagate the update to the other processor, there is an increased overhead of this message passing. Because the processors are greater in number, so now the updation and the message passing on the modification will be also increased. So there is one overhead of this replication process that is associated with this data. Now propagating the updates in every of the processor in a centralized system is much more complex. While being the distributed system, it is very easier. We can use the concept of a primary copy. Say for we are detecting a replication of this copy Ri as the primary copy. Now this Ri is being accessed by this Pi. So now my Pi becomes my primary site. So using the concept of this primary copy, that every update first need to be make it to the primary copy or this Pi. So whatever we are associated site or the processors with this Ri, we need to first update with this Ri and then the update will be propagated to the other states. So in this way the overhead of every process communicating or message passing the update with other process is greatly reduced, because now my Ri be the central site on the primary copy and they will keep the update propagated to every Rj, Rk, Rl that belongs to Pj, Pk and Pl. So in this way the primary copy moves the overhead contention for the replication process. Now that we know about the replication, that is an advantage of the increased parallelism and also the data become available, but also the data storage cost is involved. So other than the overhead of message passing the updates, there is one more cost that is associated to it, that is in data storage. Now we will need a great number of storage, and if it is a large database, then it is extremely important to have the data to be stored in a fragmented way, not a replicated way, because for replicating a large database it will need a many greater number of storage areas. So now the next concept arises with the problem, that is in fragmentation. In fragmentation, we divide the disk, that means the database, into different parts of the disk in such a way that the disk or the parts can be computed by the processors independently. So now even if the problem with the replication, say suppose that P1 needs only the Ri and Rj portion of the data to be updated, but they given the total copy of R as a copy to the P1. But if we fragmented the data R in such a way that R1, R2 to Rn, so now each of this copy has been stored in D1, D2 and Dn. Now the P1 can access to D1, D2 and Dn depending on the area it needs to access on the relation. So fragmentation is in clear better way than replication, because now only the portion that is needed by a processor can be accessed by it. Now there are two types of fragmentation that is included in this distributed data storage. One is horizontal fragmentation, another is vertical fragmentation. If you look at a relation that has got the horizontal, which is the tuples of the relation, and now if we got this vertical, then we have the attribute or the fields of that relation. So now the horizontal fragmentation means the tuple wise we are fragmenting the value. That means from each tuple we are storing it into the disk, or at least for a selection of tuple we are storing it into the disk. So this horizontal fragmentation becomes easy and useful when we can have the tuple-wise information. And the vertical fragmentation goes with where we can store each of this attribute into different types of disk. So now for the tuple-wise or the horizontal fragmentation, say if there is a set of tuple Ti, Tj to Tk, so now we can store them Ti to Di, Tj to Dj, tk to dk, where both of this ty is greater than equals to 1. That means the tuples that is belonging to a disk should be minimum 1 and it can be greater than 1 based on some predicates. Now what do you mean that greater than 1? That means there is a predicate, then we can select a number of tuples inside a disk. Now there should be at least one tuple that belongs to a disk, so that when we are recollecting the data or refragmenting the data, then we can get the actual database very easily. Now storing the data in this databases tuple wise, we can store it in a round robin method where we can have, see, the order of 5. So now we can store every 5 tuples in a disk. Say suppose that there are 50 datas which we need to accumulate into 25 disks. Now how we can do that? We can go for the first 25 with this 25 disk, as we have 5 tuples in each. That means they will need only 10 disks to be filled up, and other remaining 15 disks will be empty. But as we know that we need at least one tuple to be reside in the number of disks other than when the disk skew to be happen. So how can we this? We can reduce the number of order. So if you reduce the number of order to 2, then we can have that every 25 disk is having 2 tuples in each. Now if you reduce the number of order to 1, that means every disk is having only 1 tuple. Then the 50 can be generated with 25, that the first 25 tuples are go to the first 25 disks, and the second 25 tuples again goes with a round robin method, that the 26th one goes in the first one, 27th one in the second one, and the 50th one in the last one, and the last one go to the 50 to this 25th one again. Now that we are using the horizontal fragmentation, we can use that within a silicate. Now say of the account information which has the account ID on the name and the account branch and the balance. So now we have the account relation with the ID, the name, branch and balance. Now this ID and name is the account number and the name of this account owner, and the branch and the balance and the branch of the account and the balance on the account that it remains. Now say suppose that we want to select a particular segment on which we are having the branch. Say suppose that we have only 2 branches onto this bank. Say on the hillside branch, another is the Perryside branch. So how we can select the tuples that is distributed into 2 relations? We can select it by, so in the account 1 fragmentation, we are having selecting the branch name equals to hillside on the account. So now every tuple that belongs to this hillside branch will be stored into the account 1, and the rest of the tuples that belong to the Perry Ridge branch will be stored in account 2. So in this way we can provide the horizontal fragmentation. See, for a general rule, if we are having R0, R1 to Rn number of fragmentation in an horizontal, then we can define this as, now we can have the Ri as a selection of particular predicate Pi onto this R. So now the predicates need to be unique for each of the selections, so that we can make a logical boundary on each of these accounts or each of the fragments on an horizontal or tuple basis. Now that if we want to rejoin this fragmentation, then we can perform this R0 union R1 union R2 union Rn. So this is the formula for refragmenting these documents. Now we can either go for this refragmentation, and this Ri, Rj, Rk are all disjoint fragmentation. That means that if Ri is having a set of tuples, say T1, T2, T3 based on some predicate Pi. Now the Rj can have the set of tuples T1, T4, T5 based on some predicates Pj. So the same predicates or the different predicates can go with the same tuples that appear in both of these relations. So that is the formula for having a disjoint relation. That means whenever we are doing the horizontal fragmentation, we may reach up in a condition that the same tuple is belonging to different sections because the same predicate or the predicate is giving us the same tuples. But the predicates need to be different with each other. That is, we must maintain the condition that Pi is not equals to Pj. Now let us go for this example so that we can know how a disjoint fragmentation can be appear. Say suppose that we have executed these two queries. One is salary greater than 50,000 and one is salary greater than 70,000. Now the range from 50,000 to 70,000, we will have the tuples common in this both. That means now, say suppose if there are T1, T2 to Tk number of tuples in this account 1 and in this account 2 we are having, because all the salaries that is greater than 70,000 is also greater than 50,000. So the constraint is that 50,000 to 70,000 will be only present in account 1 and not in account 2. But other than that, all the tuples will common in nature. So we will restrict our use of the disjoint fragmentation in such a way that we cannot have or we do not want to have more tuples that are common in different fragmentation, because that will not only be an illogical but also an extra overhead of keeping the storage and keeping the tuples in different fragmentation on the same basis. So we should better choose a logical way to define the horizontal fragmentation. Now let us go with an vertical fragmentation. Now with the vertical fragmentation, we have the R relation with R attributes. Now we will have the attributes as the fragmentation. So it can happen that there is one attribute in one relation that we have fragmented, or more than one attribute combined together to have a logical relation. Now there should be that restriction that we can include at least one relation attribute to one fragmentation. That means if we have divided to R1, R2 to Rn number of fragmentation in a vertical one, then to every processor P1 we need at least R1 which is greater than equals to 1. That means there is at least one attribute confirmly into one relation or the fragmentation. Now how we can divide this internal fragmentation on this horizontal or vertical basis? Now inside the vertical fragmentation we can have the general rule that is defined as Ri equals to projection of Ri on R. That means we are projecting the particular attribute on this relation. So we can have the combination of the selection and projection as well as a horizontal and vertical attribution, and also we can have only this projection as the vertical fragmentation. Now that we are having this Ri on R, that means we will select a particular attribute R that belongs to this relation smaller. Now if we want to refragment the data that we have internally fragmented in a vertical basis, can again be joined with a natural join operator. See the difference, while in the horizontal fragmentation we have used the union operator, but for the projection we need the join operator, that is a natural join operator. So to refragment it we need this R1 join R2 join R3 join Rn. So now let us take an example and see how we can divide this internal fragmentation on a vertical basis. Now one way to ensuring that the reconstruction on each of this R1 to Rn can be with R, that is the insurance of the primary key attribute of R that belongs to each of this relation schema of R1 to Rn. See, for an instance, we can attach a tuple ID with this each of the fragmentation so that the tuple ID become the primary key. So any of the R1 or the Ri, the primary key becomes the tuple ID. So the tuple ID cannot be duplicated with each of this relation and thus give the primary key constraint. So while joining this one, we can have this tuple ID as the joining constraint or the joining attribute. Now, how we can achieve this primary key constraint without it having in the R relation? Say suppose that the R relation is having the primary key account ID. Now, how we can have this account ID be generated with every such relations which is not a desirable one? Say the R1 is having the account ID name, second one is having account ID balance, account ID branch. Account ID is being redundant in this relational schema where we are going for an vertical fragmentation. So the tuple ID as a primary key will be a better choice than the primary key constraint on a relation. Now if you look at this example, now what we can have, this employee is having EID name, post and salary. Now we can have its personal info and the business info divided into two relations that is having the horizontal fragmentation. So now these two relations is having the horizontal fragmentation where the personal info consists the post and salary of an employee with the EID being the primary key, as well as the public info we are having the EID and its name. That means for security reasons, so we need to build a logic behind horizontally fragmenting a relation. Say for the security reason, we do not want the post and salary to be disclosed to everyone of an employee. So now we can know the employee ID and name, and for going to the post and salary, the personal info is accessed. So in this way, we can fragment the horizontal fragmentation. But there is one way again that we can again fragment this horizontal fragmentation in an horizontally and vertical way. So it is not restricted that we can have only one number of fragmentation. We can have a couple number of fragmentation on which a relation is basing. So now we can have a better distribution of data so that the processor can get the exact data on which it's want to process. But we need to maintain some logic relations between them so that we do not go and in such a way end up in a relation that needs another relation to participate for doing an access. Now the next one is transparency. Now while we're talking about the distributed data storage, the term distribution goes with that it is distributed among many of the processors or the users. Now when it is known that where to store the data, how to access the data is not redundant or mandatory to the users, then it becomes a transparent database access. That means the user can access the data without knowing where is the data storing or how to access the data. Now there are many types of transparency. The first one is the name transparency. So the name transparency go for two in this case. The first one is the fragmentation transparency, the next one is the replication transparency. For the fragmentation transparency, we do not need to know that what fragment is storing what data. Say the user is not the one who wants to know that which fragment is storing my name and which is the post and salary. We just want to access the data. For the replication also, that which processor is storing the which type of data or which replication copy of data, it's not known to the user. And the last one is the access transparency or the location transparency, that where the data is being stored. It is stored in the disk D1 or disk D2. That is not any case of the user. So this transparency are provided to in the distributed data storage systems. Like when we are having the transparency to the user, then one thing we need to keep in mind is the naming of these databases. Now if we have the naming, that if we can create a name server which keep access, say the name server is having access to all the names that we are providing, say for the account 1, account 2, employee info, employee personal info, and every time a new name is being attached, it is being attached to this name server. And if a new name is found in this name server, then it is checked that it is already belonging to the name server or not. Now if it belongs, then we cannot have that name for that particular copy of the data. Now what is the use of this name server? That it keep tracks of all the names, and from this name server only we can access the fragments or the replication copies. Now what happens, and the disadvantage of this name server is whenever the name server fails, then we cannot access the entire database because all storing the names on the name server. And also the name server becomes a performance bottleneck while we are having this name server itself as a part of this database. So then better alternate approach is to store the data into different sites. If we store the data into different sites and use the site ID as a particular information, then we can have every site with its site ID as a primary key. Say suppose for example, other than naming it to account 1, we can name it to site17.account, or even we can go with account@site17. So many of the system uses its URL or the internet copy for that naming on this name servers. And other than that, it can directly use the site ID as a primary key to that number. Now in this way, we can name and problem creating the aliases of this num servers so that we can access the distributed data storage in a proper and efficient manner. So this is the fragmentation, replication, and the transparency to the data storage that we can use in a distributed environment. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.